Back. Today we're looking at exponent rules, more specifically the power and product rule. So let's go ahead and look at what happens if we have x squared times x to the third. Now the trick here is we want to try to find a way that's going to make it easier for us because, well, I'll show you the long way. So what all this means is that we have x squared, which is x times x. I'll put that in parentheses, right? And then times x cubed, which is x times x times x times x. Right, now, because we have all multiplications here, we can say that this is going to be x to the fifth, right? And then we'd have it in simplest form. Now, what we're trying to do here is we're trying to skip this step and go from here to here. Now, rather than having to write it out, because what if we had x to the 1,000? We would not want to write 1,000 x's for sure. So the shortcut here is, rather than multiplying them out, which you can still do, right? If you forget the rule or you're not quite sure, go ahead, write them out. You'll get the right answer every time. But if you can remember, anytime we multiply numbers with the same base, right? The same base, we have x's here with exponents. So when we multiply same base, all we have to do is add the exponents. Right, so the simple way is, oh wait, we have multiplication, we have the same base, 2 plus 3 gives us 5. Nice and simple. Okay, so just a couple examples, or a few examples. So y squared times y squared times y. Now be very careful, even though we don't have an exponent on the y, we assume it to be 1. So if we're adding those exponents, then this should be y to the fifth. Right, and then next example, don't let them fool you by making things complicated. We only multiply numbers with numbers, multiply the y's with the y's, right? So negative 7 times 5 is negative 35. You can take care of those constants first. And then y to the first, right, we said technically is to the first, times y cubed is going to be y to the fourth. Okay, and then the last one is just a check. So remember, again, we're only doing our same variables, variables with the same base. So x to the 1 plus x to the 9, that's going to give us x to the 10. We can multiply every single one of these, no matter if they're with the variable or not, because we treat all constants like the same. So 2 times 3 is 6, 6 times 8 is 48. And then we can deal with our w. So we have w to the 8th. W to the 7th, well, 8 plus 7 is going to be 15. And then you're done with that. Now the power rule is a little bit different. So one thing to remember here is anytime we have parentheses and exponents and stuff, it can get real tricky knowing what to do with them. But the exponent only applies to what it's next to. Right, so in both of these cases, the exponent is applying to the parentheses, which means the whole parentheses, because it's next to the parentheses, if that makes sense. So what this means is this would be 4n times itself. And in the other case, it would be u cubed times itself 3 times, right? Because we have the cubed outside. Okay, which means we do our multiplication just like before. So 4 times 4 is 16. N times n is n squared. In this case, we could write out all the u's, but then we know the product property anyway. So 3 plus 3 plus 3 is u to the 9. Right, so just like we did the last time, we're trying to figure out a rule here that works. Rather than having to write it out this way, all that happened was we squared all the parts inside, right? So then in this case, we squared all the parts. Technically, it's to the first power. Now, this case is interesting. So the 3 on the outside and the 3 from the inside exponent, all we did was multiply. So in this case, power of a power. And keep in mind, these are all power 1s right here, yeah? If we're talking about things that don't have an exponent on them. All we have to do is multiply the exponents. So technically we had 4 to the first times 2 is 4 squared. Oh yeah, 4 squared is 16. N to the first right? We don't have a power on there, but n to the 1 times 2 is n squared. Oh yeah, there's our n squared. So it can be tricky thinking in terms of multiplying if we don't have an exponent there, but remember, if we don't have an exponent, it's assumed that the exponent is 1. All right, so let's get into some harder stuff. It's only harder because we have multiple things going on here, but it's displaying the power rule. So 5 doesn't have an exponent to the first power, so we have 5 cubed. We'll write it as that now, we'll get to it later. And then 4 times 3 is 12, so W12. Y doesn't have an exponent, so 1 times 3 is 3. And then if we do 5 cubed, because we can simplify that, that's going to be 125. And we just do each part separately. On to the second one. So this time we're doing it each part. So 5 times, well, let's do -2 to the 5th, right? Like we did there. We're going to deal with that later. Then we have v to the 5th over u to the 3 times 5 is 15. Now -2 to the 5th is going to give us -32. Okay. And then the last one, it's got a couple parts going on there, which makes it look super complex, but it's not too bad. Same idea. So -x squared to the 4th is going to be careful here because it's to the 4th power. Negative times negative is positive, times negative is negative, times positive is positive again. So because we have an even exponent that we're raising that negative to, it's going to become positive. So it's going to be x to the 2 times 4, which is 8. Y to the 4th, z to the 4th, so that's this whole first part, times 3x cubed y squared, right? We didn't change that part. Okay, again, now we're going to apply our product rule stuff. We're putting our x's together. Actually, let's keep this 3 in front. So we have 3, and then x to the 8th times x to the 3rd. We know we're adding those because it's multiplication, so we have x 11. Onto the y's, y to the 4th times y squared, we know we're adding those, so that's a y to the 6th. And then this z is alone. And then we're done. All right, so a lot of different types of problems today, but again, the concept is the same throughout. We have the multiplication ones, the product property ones, where if we're multiplying same base, we just add the exponents. And then the power one is anytime we raise a power to another power, we just multiply those two numbers. So it's just a bunch of different examples, different complexities of examples, but same idea. All right, make sure you have any questions, you write them down. We can talk about them next class. Good job.